Bismillahirrahmanirrahim. So my topic is involvement of Piezo-1 ion channel in the regulation of acetylcholine release in the mouse urinary bladders. Urothelial cells have the ability to sense changes in their extracellular environments and respond to various stimuli by releasing numerous neurotransmitters such as ATPs and acetylcholine. Piezo-1 channels has recently been identified is reported as a mechanically activated cation channels to mediate ATP release in the urinary bladders. So our aim and objectives to localize Piezo-1 expression in rat urinary bladder, to investigate its functional role to mediate acetylcholine release in extracellular environments. The method we employed, the specimen urothelial cells are isolated from the young bladders from 2 to 3 months old male mice. Then we'll use the immunoreactivity for protein expressions, PCR, real-time polymer chain reactions for expression of this Piezo-1 ion channels. Then Piezo-1 siRNA treatment is used to knock down the Piezo-1 ion channels, and then amplex or red acetylcholines cholinesterases assay to measure acetylcholine release from urothelial cells in response to 50% hypertonic solution induced stress. The kits are used to measure the acetylcholine release. Piezo-1 expression in cultured urothelial cells. So here we check the expressions. The percentage expressions are decreased in siRNA, and its percentage decreased or increased in a control. And then when we have a scramble, that we have given another things which is not related with the any solutions. That is hypertonic induced acetylcholine release. We have made two groups. One is control and other is the stretch ones. In the control, we have given the no hypertonic solutions, and in siRNA we have knocked down the another group and make another groups. That is, we knock down the Piezo-1 ion channel blockers, and also in the third group we have just blocked the this Piezo-1 ion channels. Piezo-1 is densely expressed on urothelial cell layer of the mouse urinary bladder. Hypertonic stretch induces a significant rise in acetylcholine release from cultured urothelial cells, which was significantly blocked when clumped urothelial cells were pre-incubated with MTX, a Piezo-1 channel inhibitor, and in Piezo-1 knockdown urothelial cells. Summary and to conclude, Piezo-1 appear to be a mechanico-sensitive acetylcholine release channels in the mouse urinary bladder, suggesting that it may contribute to the actions of antimuscarinic drugs and may lead to development of new therapeutics for the clinical management of lower urinary tract storage disorders. Thanks a lot for your questions.
I have a quick question. Stretch has been shown to release ATP from urothelial cells, but when carbachol has been applied to intact urothelium, it's been demonstrated to cause calcium transits as well as stretch. So do you think this acetylcholine release is working in an autocrine fashion?
Any stretch,
or what do you think it's doing?
Any stretch which leads to the for the unrest of urinary bladders. So that may lead to, before it was that it is only release ATPs. Now it's by our experiments it's identified that it will also release acetylcholine, which is responsible for the unrest in the urinary bladders.
I'm sorry, I didn't understand that, and I realize you're working on cultured cells. But what do you think the released acetylcholine is doing? Is it working on the urothelium itself, where
yes.
there are receptors for it?
So,
or is it working in another
when
location?
there is any acid out, you may give the anticholinergic drugs to block that release. It may prevent the unrest.
Hi. So hypotonic stretch is, there's problems with it and all this stuff.
Yes.
Piezo 1 has a specific agonist now called Yoda 1. Have you tried that to see if you can recapitulate your data with the hypotonic stretch?
Not yet.
Okay. All right.
Okay.
Any further questions? Thank you.
Thank you very much.